Good morning, students. Good morning. So inform everyone to join quickly so that we can start. So I guess we can start, right? So inform all to join. Okay. So hello everyone. Good morning. This is a class of uh, professional elective 3 of 6th semester, and that is rural water supply and on-site sanitation. Okay. So we are discussing about the module 3, right? So if I am not wrong, it will be third or fourth class. I'm a little confused about it. Maybe third class. Third class of your third module. Fine. So till now in this module, we have discussed about what? We have discussed about water distribution. Okay. Or why we need a distribution network in a particular area or community. Okay. What is the uh, significance or benefit, you can say, benefit of a proper planned distribution system? Okay. We have already discussed about that. We also discuss about different types of uh, water distribution system, like different pattern of water distribution. Okay, I think you have remember like rectangular, radial. Okay, there are four or five types of pattern. We have already discussed about that. Fine. So in the very last class, we are from very last class we are discussing about the water supply during emergencies, or you can say in festival. That means in a particular situation where we need a sudden there is a increase in sudden increase in demand of water, like in case of festival, or you can say emergency. But when it comes to rural water, or you can say the rural area, then we'll give the preference to the emergency, not like festival. Okay, but they are similar to whatever we have already discussed, and we are going to discuss today also. These things are all factors are very same for emergency, festival, all there. But for rural area, but preference should be given to the emergency one. That means in a particular situation where uh, the provision of the decentralized water supply from the government or from the higher authorities failed, or you can say unable. In a particular situation, how can a particular household living in a rural area can get appropriate amount of water which is also drinkable or safe for drink? Clear? So in the last class, we are discussing about the rainwater harvesting, you can say, how to utilize rainwater for drinking purpose or in other purpose. This is a very serious topic, even in India right now. Most of the people are not going for the construction of rainwater harvesting because they are not aware of that importance of water shortage. Okay, if you go through the deep informations or deep knowledge about groundwater depletion. Okay, so in even in city like in Guwahati also, there is a very serious case of situation of groundwater depletion. That means the groundwater is going down and down and down. That means even the groundwater, uh, the water available in groundwater will also be going on decreasing. But in that scenario, in coming years, from research, it's found that it's going to be very difficult for us to survive without water. So for that, we have to go for that, uh, backup plan. You have to come up with a backup plan. So what is the backup plan? That is a scenario of emergency, okay, which is coming now. It's going on, but it's not that all are aware of that. Most of the people are not aware of that, okay? Because when you are going for construction of home, we are not most of the people, more than you can say more than 60% or more than 70% of the people uh, doesn't give importance to the rainwater harvesting, okay? Or you can say groundwater recharge. So this particular emergency situation is coming very soon. Anyway, so as an engineer, you should aware of that. You should realize the situation, and you have to know how to tackle that situation. One of the solution is what you have to utilize the rainwater. Okay, most of the water going to the ground or a river, most of the water is your groundwater. Fine. So we are also going to discuss about little bit about groundwater even in the class also. Anyway, so in the last class we are discussing about rainwater harvesting in household. That means individual household can go for constructing a setup for uh, collecting the groundwater, okay, filtering the groundwater and storage of groundwater for future work. Fine, these things we have already discussed in last class. In today class also, we'll start from that. This is the continuation of the last class. Today we're going to discuss in community level how can we go for storing the rainwater. Fine, is it clear to you? So let me share my screen first. Okay, my screen is visible, right? Please to respond. Yes or no?
Sir.
Okay. So in the last class, we are discussing about water supply during festival and emergency or fair, whatever. So we have discussed about basic source of water, then rainwater-based rural water supply system, and under this we have discussed about roof catchment and storage. So about this household setup for rainwater harvesting, we have already discussed in the last class. Fine. So let's close this. Let's go back to that. Yeah, ground catchment and storage. So this ground catchment and storage can be done in the open space. Okay, so I'll not go in line by line. Okay, so you can go through this everything. So I'll just go in the roughly so that you can understand all these things. Okay, anything. Anyway, so here you can see some special summary notes are given here. The in rural or outback areas, conventional method of water sourcing, extraction and supply are not cost effective. Okay, why that is the case of uh, some in some areas the decentralized supply water is not possible somehow. Okay, it is a case of we can say the emergency, or this is an issue where we can have to adopt some natural process or local process or approach you can say for consume water, right? Especially no so in the rural areas of developing countries which need simple alternative methods to satisfy their domestic water needs. Water supply to which rural communities can be sourced from rainwater, groundwater, and spring or surface water like that. So we can go for collecting water from rainwater, even from the groundwater, okay, and spring, surface water, all these things. Okay. So through simple rainwater harvesting technique, household as well as the community needs for water in arid and semi-arid regions where no other water source are available for or feasible can be met. Okay, and groundwater is by far the most practical choice for safe water supply. So about that, about this groundwater water supply, we're going to discuss this. Okay, we're going to discuss about that. So I think this is the whole scenario of need of water in emergency or you can say the festival. Okay. So basically, I'm showing you this diagram. Even from the diagram, also you can understand the what is all about the ground catchment and storage. Okay. So here you can see how to create or how to construct this kind of setup for collecting water even itself in the ground. So first of all, and in a very basic information, even from the picture, so you can say what is the information you have right now. Suppose this is your outlet. Okay, that means all water. Okay, suppose this is your target area. I'll just take a pen. Right. Okay, suppose this is whole your target. Sorry. Okay, this is my mouse. Okay, so in this picture you can see this is the target area. Okay, this is target area and this is your output. This is your output. That means the rain coming on this particular ground, they are diverted or directed, you can say directed to flow in this direction, and the particular water is stored in this tank. Fine, this is a very simple construction, you can say, but little bit engineering will be added here, because you suppose the particular area that you have selected, it is not uh, inclined. First of all, whenever you select a particular area, you have to first find out what is the higher elevation point and what is the lower elevation point. And from how can we find out that? How can you find out whether the which point is in a higher elevation or other, which point is lower elevation? How can you find out? You are an engineer. You are kind of a, you have to know these things. Do you have any answer? What method you are going to use? Anyone? If somebody asks you that, if somebody gives you this particular area and just asks you to just find out the elevation, how can you find out? Anyone? Don't think about only that one, water resource hydraulics. Okay, you can contact or you can connect with the different subject also. How can you find out the elevation of the particular area practically? Okay, chalo, no responses anyway. So you can go for contouring. Okay, from, I think you remember from surveying subject, you can go for contouring work. From contouring you will find out the higher elevation, which one is higher elevation and which one is lower elevation. From that point of view also, selecting the lower elevation is the outlet. You know the water is flowing, always flow from higher to lower elevation, right? So you can select a particular area which is at the lower elevation and direct it. You can divert the water, rainwater, which is coming as a surface runoff, to flow in a particular tank. And you can also create this particular reservoir, water reservoir, above the ground level or below the ground level. Okay, there is a, you can also go for that. So like this, the water coming as a surface water is also be stored in water, stored in this particular tank. Also the particular which is infiltrate and also flow like a groundwater can also percolate in this. There is a provision, should be a, there is a provision to uh, so that groundwater can also be uh, enter this particular tank. Okay, and the size of the tank is depend on the rainfall intensity, what is, and this area. That means what is the amount of water, rainwater will come on this particular area, and how much quantity of water will can be stored in particular tank. Depending on the water quantity, we can design this um, tank. Fine. So this is very basic diagram for ground, catchment and storage. Here you can see there the slope is what, 1 in 20, 200, sorry, 1 in 200. That means for every 200 unit, one depression, or you can say inclination. If you say from this point there will be inclination, and from the other point you can say it's a depression. Fine. Even from this side it is 1 in 40. That means one unit depression for every 400 land. Okay, so like this, from the natural ground you can go for rainwater harvesting. Okay, if this not ready, or it is not ready for, suppose this particular slope is not there naturally, then you can also go for preparing this particular slope manually, or you can say by yourself. That means you can also prepare this land so that all this water can divert in this particular reservoir. This is all about the basic idea about ground catchment and storage. Okay, now let's go the statement it is given here. Okay, now by appropriately preparing a piece of surface on ground, it can be used as a catchment for harvesting rainwater for small community. Regarding catchment, also you know these things, right? Even in fluid mechanics or hydraulics, I think you have got, or maybe you are getting right now in semester. So catchment is a particular area where there is a one common outlet. Okay, so this particular area is you can consider as a catchment. Okay, either it's a natural or it's man-made. Okay, man-made. So in this particular catchment, where there is a one common outlet where um, all the rainwater coming on this area, all rainwater will only go through this, will come to this outlet. This is a common outlet. So this is a catchment having one common outlet. Fine. So by appropriately preparing a piece of surface on ground, it can be used as a catchment for harvesting rainwater for small communities. Okay. A part of rainfall will serve to wet ground and get lost due to evaporation filtration. So this thing we are going to discuss even in the diagram. I'll show you a diagram. The whole hydrological cycle. Fine. So the considerable reduction in such loss can be attained by making a catchment surface smooth and impervious using clay and tile. That means, suppose in this area you are using for rainwater harvesting. Okay, that means you are not allowing, so for that you are need more water in this tank. You need more waters so that it can flow as a surface runoff and reach the this reservoir tank. You should not want the most of the water is going inside the ground as of infiltration. Okay, that means we need to make um, this ground, this surface impervious. Impervious means it should not allow the water to penetrate into the ground. By how can you make it? By using clay, tiles, asphalt, or plastic sheet like that, so that water should not penetrate into the ground. Okay, and it directly stored in this particular reservoir tank. Fine. Okay, so ground catchment. So basically, it is a ground catchment. Ground catchment involves land alternation for contouring. Okay, clearance of rocks and vegetation, simple soil compaction, preparation of surface. Okay, to reduce infiltration, construction of ditches along the contour, and construction of storage tanks. Fine. So basically, how can you go for this preparation of this ground catchment? So for that, you have to first prepare the land, compact the soil so that voids can be less, or you can also use clay soil over the surface so that you can make the surface impervious so that water should not be penetrate into the ground. Remove all the vegetation to make the surface smooth so that water can directly come to that particular reservoir tank. Okay, like this. Construction of ditches. That means this is a ditch. Okay, these are the ditch. That means water first. Okay, I'll just take this second pen. Wait. Water coming on this particular area, it will just follow along the ditch. Okay, then it will just follow along this direction like that. Okay, all these are ditch. I think in this kind of ditch you have seen in this agriculture field. Okay, the water is uh, targeted to flow through this ditch and directly come to this reservoir. Fine. So this is a approach how to go for ground catchment for rainwater harvesting. So this is the basic diagram. Well, this is a collection drain. You can see basically this is the main collection drain, rainwater collection drain, and from this drain is connected to reservoir tank, where also some valve also be added here. This thing, I think the basic thing. Okay, or you can say the screening will be also be there so that to remove the debris. Okay. Okay, the storage facility for groundwater catchment rainwater harvesting system can be either above ground or below ground. So the reservoir can be above the ground or below the ground. Whichever the type of the storage, it should be protected from contamination by providing an adequate enclosure that prevent entry of pollution. So of course you should make it confined. This particular reservoir tank, you need to make it confined so that impurities or foreign matter should not be um, mixed with water. Okay, fine. These things are, you can also read from yourself. Okay, so you should not make a place where water can stock and where a mosquito breeding could be a case. Okay, so you should also be aware of this mosquito breeding. Okay, yeah. And how can you make it? Either we can make it. Suppose we are making for a small community, very small community. You can go for going for building with a clay or wood or waterproof bamboo framework. Okay, and if you are going for a larger one, while using a larger storage tank, then you can go for constructing the storage tank by using stone, brick masonry, okay, or RCC, okay, or ferro cement. That means RCC work can be done for a higher capacity water tank. Okay, so this is a basic component of reservoir tank. Okay, so this is all about your groundwater, sorry, your ground catchment and storage. Okay, so next we are going to discuss about the groundwater. So till now we are discussing about only rainwater. Fine, that means surface water that we are collecting from the surface, we can collect it and we can go for consume it after filtering. Fine. So till now, do you have any doubt? If you don't have doubt, then we can go to the next phase of that, uh, that is your groundwater and how to use a groundwater. Is it clear till now? You can respond at least. Okay. Okay, these things are not that complicated. Okay, I think from your side also you can understand by reading only. Okay. Anyway, fine. So let's go to that groundwater. So before going in the uh, groundwater-based water supply system, first of all, you have to understand what is groundwater first. Okay, let's go back here. So I'll not go in very detail of this thing or what is basically groundwater. Okay, so I'll share this note. You can just read out from yourself. But I just make you overall a summary of the particular groundwater. I think you have already heard this term. What is groundwater? You know these things. Okay. So basically, what is groundwater? How a groundwater can be generated? So this is it's a result of groundwater hydrology. You can say how can a groundwater can be stored? Okay, this is a basic hydrological cycle. You know this thing. Okay, you have got this thing in very beginning. So here you can say this is a total water cycle or hydrological cycle. You can say this is, you can see, from total 100% precipitation. That means this is a particular amount of water coming as a rain, 100% on the land, and from this 100% of the rain coming on the surface, some part is flow as a surface runoff. You can see this is your surface runoff. This is a surface runoff. They all are surface runoff and going to the reach the ocean finally. Okay, this is a surface outflow or surface runoff, you can say. Okay, and some part of the rain, or you can say the precipitation, that means the rainwater, is penetrate into the ground as an infiltration. You can say this is an infiltration. Okay, this is your infiltration, and finally they reach the ground water movement. So you can see the groundwater movement is the water uh, which is moving under the ground. This is your groundwater. Okay, and finally this is yellow one is your impervious strata. That is water cannot penetrate into this particular strata. It is particularly, you can see that it is a rock. Basically it is a rock. Okay, beneath the earth, you can say there is a rock, and water is stored between the rock and the top surface of the earth. Between these we have the groundwater. Okay, and the groundwater also finally they reach ocean. Okay, like from seepays. Okay, sometimes groundwater also come out of the ground as a spring water. Fine. So basically this is a basic hydrological cycle of rainfall, or you can say, or hydrological cycle. simply. Fine. So these things I think you have it is known to you. This is another diagram. You can also go through this. It's a very basic diagram. Okay, this is a land surface. There is a surface water. Under this there is a groundwater. Below this there is a groundwater filled with um, soil particles and fracture of rock. Okay, so all these things are there. Anyway, so in groundwater can be divided under four types basically. Do you know what are the four types of layer under groundwater? Anyone? Just right here only. So groundwater is a basically you will get in four type of geological formation. Okay, there are, you can say, there are four types of groundwater, four types of geological formation. Sorry, four types of geological formation for groundwater. So do you know what are the four types? क्या क्या है? One is your what? Aquifer, right? These things I think you have got these things right. Aquifer. Then what do we have? Equiclude, isn't it? My spelling may be mistake. Okay, just cross check. Okay, Equiclude. Then Equitard and what is the last one? Equifer. So these are basically a geological formation where you can find groundwater. Even in the aquifer, even in the aquifer, we have two type of aquifer. You know, na? Okay, I'll show you. Okay. What is your what? Anyone? Do you know types of aquifer? Anyone? पता है कि नहीं? नहीं पता है? So we have two types of aquifer, or you can find two type of aquifer under the ground. That is your confined. First one is your suppose confined, not first actually. One is your confined aquifer, and another one is your unconfined. Unconfined aquifer. Okay. So basically, they are basically a geological formation only. Okay, geological formation. So basically, that aquifer is a pervious formation. Pervious means water can flow over this layer, across this layer. Okay, it is pervious. Pervious layer, you can say, or pervious formation. Both are this unconfined or unconfined aquifer. Both are pervious formation. Okay, that means they are permeable. You can say pervious means permeable. Okay, or you can say it is a saturated formation. That means water is always there in aquifer. Saturated. I'm just giving you a point wise, okay? Saturated formation. Fine. It's a pervious formation of earth. You can say pervious formation of EA. Sorry, pervious formation of earth. and it is saturated formation. Okay, and basically, if it is permeable, that means it is a combination of what? It is a formation of basically it is a it's made up of sand and gravel basically. Okay, sand and gravel. I think here also it is given here. Let me check. Aquifer, yeah, yeah. See, you can say aquifer is a typically made of gravel, sand, sandstone, and like that. Okay, water can move through this material because they have a large connected space that can make permeable. Okay, like this. So if you want to see actually how aquifer can look like, you just search in, you can Google. You see, you will find out like this. I think I will show you some image here. Yeah. So here you can see this is aquifer. You can see that how confined aquifer, unconfined aquifer. Okay. So basically, I have already told you what is aquifer. It is a geological formation. It is basically made of gravel, sand, all these things. Okay, that means water can cross or pass through this particular layer. Fine. Now there are two type of aquifer. Yeah, one is your confined and unconfined. Okay, basically you will get this unconfined aquifer nearby the ground. Suppose this is a ground surface. Okay, nearby the ground you will get the unconfined. Unconfined means what? From one side it is maybe confined, that means water cannot pass, but from other side it is water can be passed. That means you can see this is a water table, right? You can see this is a water table. I have already mentioned you, this is a groundwater table. That means water can be percolate into the ground surface. That is, it is unconfined. From top surface water can percolate. That means we can get the water even from the water table itself. Fine. Now unconfined aquifer means what? Unconfined, sorry, this is an unconfined aquifer. Okay, unconfined means from top side it is permeable. Fine. And from the bottom side it is impermeable. That means water cannot pass through this, but water can pass through from this side, because you can say it made of maybe sand, gravel, like that. So water can pass, okay, in upward direction. But below that this water layer, you will see what is the layer. It is there, clay layer is there, right? This is just a uh, this is not a real scenario. This is the just a animation diagram so that you can understand. Okay, so below this unconfined aquifer there is a clay layer, and clay is a less permeable soil. Okay, having less voids, the water will very it is very less chance of water percolate through this layer. Okay, it is a compacted clay layer, so water will not pass. Will not means there is a very difficult to pass for water. Okay, that means from this side you can say the water is blocked. That means that's why it's called unconfined aquifer. Okay, now when it comes to this soil, this water layer, which is confined aquifer, it is noted here. So below this layer it is what? Bedrock. The all are rot. Okay, bed rocks are there. Okay, and above this clay layer, that means water will not easily come upward direction or below, downward direction. Okay, that's why it's called confined aquifer. That is, it is confined by both direction. Okay, water can travel along this lateral direction but should not go through this. So what do we do? What to get the water from the groundwater? What do we do? We do boring to the confined layer. Okay, you usually go for boring, right, in every domestic area or even industrial area. Okay, for collecting water from ground. Basically it is done on the confined aquifer. Fine. From confined aquifer means what? It is confined from both direction, and only we have to go for creating some hole by going into boring, deep boring through that particular area. Okay, and below where there is a rock formation also be there. Okay, and from water, it is from this layer we can uh, collect water. Okay, so this is the way we can go for using groundwater by using boring or tube well. Shallow tubewell is inserted where? Inserted into unconfined aquifer. Okay, shallow the particular hand pump, you can see, hand water pump. It is inserted to unconfined aquifer, which is located in a shallow depth nearby the ground. So we can go for it. For boring, it is done to the unconfined aquifer. Boring is done to the deeper depth of the ground, right? So it is coming basically targeted the confined aquifer where the water is stored. Okay, it is the water can be stored for years and years. Okay, and to store the water in confined aquifer also is very, it's take long time. It take 100 years or like that. Okay, that's why the groundwater recharge is very groundwater depletion is very serious case right now, because nowadays the groundwater is going on down, the groundwater level is going down. Okay, now we have to be very serious about that, how to go for recharging the groundwater. Okay, and it is take long time, years and years to fill this groundwater. Okay, because the present groundwater we are uh, having in the underground. Okay, I am talking about confined aquifer one. Okay, so basically the deepest water level, it is basically is stored here long time ago. Because of the long time process, it is present now. Okay, it's take long time. So if you are using this particular water, okay, if you are making it is empty, to fill this particular aquifer, fill this groundwater, it's take again hundreds of years. Okay, so it will be very serious issue for us. So that's why we have to go for adopting rainwater harvesting or groundwater harvesting like that. Okay. Anyway, so this is the basically about aquifer. Okay, so about confined or unconfined aquifer. So like that, we can have it is basically made of, aquifer is made of sand and gravel basically. Then we will come to the Equiclude. Equiclude is basically, it is also impervious formation. Okay, Equiclude, it is a impervious formation. Impervious, impervious formation. Okay, aquifer is a pervious formation. Equiclude is an impervious formation basically. So water stored in a particular equiclude cannot move. Okay, impervious formation. So basically, impervious means what? It is formation made of what? Clay. It's made of clay, right? So in this particular, this layer, you can say this is a equiclude. It is, this layer is made of clay, right? So you can consider this is equiclude, right? Fine. Then we have what do we have? Aqueduct, right? Okay. Aqueduct is basically, it's also a kind of aquifer, but it is also saturated formation. It is also a saturated formation. Let me copy here. Aqueduct is it is also a saturated formation, but basically it is partly permeable. Okay, and it is made of sandy clay. It is not exactly sand and gravel. It is basically made of sandy clay. Okay, it's slightly permeable. Okay, or you can say partly permeable. Partly uh partly permeable. Okay, and this aquifer is a basically impervious and non-porous formation. It is impermeable. Impermeable means it is not permeable. Okay, impermeable and non-porous. Non-porous formation. It means what? Water, it cannot store water. Okay, it cannot store water. So what? For example, rock. Okay, so this rock, this particular bedrock, it is what? It is actually, you can consider as a aquifer. Okay, it is impermeable and impervious. Okay, that means water cannot cross through this. Fine. So these are the geological formation. Basically, we'll get water from aquifer and unconfined aquifer, confined aquifer, or basically from there also water is stored there. Okay, so this is all about groundwater. Fine, this is all about groundwater. What is the basic idea about groundwater? So I'll share this notes. We will just go through this in very detail. Let's quickly we'll go to that particular this part, that is your groundwater based water supply system. Okay, it is about time. Let's make it quick. So groundwater based water supply system, among the various source of water, source of supply, groundwater is by far the most practicable choice. Groundwater can be extracted either from a perennial spring or from open well or tube wells. Okay, whatever the well you are using, okay, that means your whatever groundwater sources you have, water supply you are getting. Okay, I'm talking about the tube well or boring. These all are based on groundwater water supply system. If you're using a spring water, spring is a part of groundwater. Suppose there is nearby there is a spring. If you're collecting water from the spring, that means it is a groundwater supply. Okay, if you're using a tube well or open well, or you can say these are actually all are groundwater based water supply, as they normally yield safe drinking water in rural areas. You also know that groundwater is nearby comparatively safer than surface water, right? In areas where groundwater is available at moderate depth, constructing a number of wells fitted with hand-operated pumps is by far the cheapest means of providing a good water supply. Even government also going through this construction of hand pump water supply system in rural areas, right? Because it's cheapest and construction is very cheap, and you can go for consuming groundwater. Okay, where the surface water is not available, you can go for groundwater. Fine. Extracting the water from the well can be done with use of simple technologies that can be manually operated, basically. Traditionally, there are numbers of water lifting devices that were being used in various parts of the world. This includes rope and bucket device, okay, then counterpoise lift and Archimedes screw. So I'll just show you some images, okay, in history, how the water groundwater collecting or water collecting uh, approaches, or you can say techniques, is evolved, you can say. Let's go that rope and bucket system. I'll show you first quickly. I'll go for it. Let me, okay, wait. Now you can see it is your rope and bucket device. Okay, rope and bucket device, it means this is the rope and bucket. Okay, here you can see these are the rope and bucket device to collecting water. Fine. This here you can see rope and bucket device, so that we can collecting. Here this one basically the from well also. Well, what do? We attach the bucket with a rope and just pulling manually you can collect water. That is simply it's a rope and bucket device, right? These basic things. Then this your counterpoise lift basically. Let's go here. From image you will understand. Here you can say counterpoise means there is a counterweight will be added here. Counter weight is added here. I can from this you can collect the water, right? And Archimedes screw. It is very interesting. So Archimedes, there is a very well-known scientist. You have heard his name, right? So Archimedes principle. I think you have heard this term, right? So Archimedes also create one Archimedes screw from collecting water. Here you can see. Okay. So there is a. You can say this is a diagram. You can see. So this is a Archimedes screw basically. Okay. So if even in YouTube also you just click on Archimedes. I'll show you fatapat. I'll show you. Anyway, you just do one thing. I don't have much time for now. So you just go through like this, selecting Archimedes screw. You just put like this. Let's see it's coming or not. Okay. So like this, you just click on this. You will find out some demonstration how this Archimedes screw work, collecting water. Okay. Like this. Okay. You just go through this, how water is collecting in Archimedes principle. Just from lower elevation to higher elevation. It is a kind of a original way of collecting water. Okay. Anyway, I'll just stop here. Fine. So basically, these particular original approaches are modified now in the form the sanitary rope and bucket system. Then bucket system is similar to the hand pump, then chain pump like this. So you can also search in Google, you will find some very good images for that. Okay. So these are the way to collect groundwater. Okay. This is approaches that can be used for collecting groundwater. Basically, we use for what? We use that hand pump, tube well, you can say. The tube well is a very good example of groundwater water supply. Fine. So yeah, this is all about today class. With this, I just want to conclude here. So let's stop my sharing now. Is there any doubt? अगर doubt नहीं तो I'll take your attendance. Okay, it's time now. Just yes or no. First right. Fine. ठीक है. So I'll just first stop my recording here. I'll just take your attendance quickly.